trust has become the default status for cybersecurity across the federal government. The parent organizations of the Defense Health Agency, the Veterans Health Administration, and the other healthcare providers in government all have zero trust initiatives in progress. Patrick Conte is Vice President and General Manager of the Americas at Fortanix. I ask him here if zero trust in healthcare is different than zero trust in other sectors.
I think it's very much the same. The issue with zero trust is that zero trust has been used as a mitigation for data risk, right? What happens is that data lives someplace, right? It's at rest somewhere, and then somebody wants to move it someplace so they can transform that data. And so while it's at rest, it's pretty safe because it's probably encrypted, and that encryption is probably pretty well known, pretty safe, at least until quantum comes along. And so they want to move it someplace. So now it's going to be encrypted somewhere in a tunnel, but it's going to arrive at a server, and when it arrives at that server, it's going to have to be decrypted. And when it's decrypted, now it's in the clear, so bad guys can come and get it when it's in the clear. So what happens is the industry, our industry, the cybersecurity industry, and the marketplace have wrapped that destination server with zero trust. And that means the latest and greatest network, endpoint, and identity and access management solutions. So they sort of like moats around that, right? And it's helped the CISOs sleep better because they think they've done everything they can. The issue, and especially in healthcare right now, is that data is still in the clear. And if the bad guys find their way through those moats or across those moats or whatever, however you want to say it, they can arrive at that server and then they can memory scrape it, or they can find some way to get not just the data, but the formula. Like, let's say it was a healthcare life sciences environment and you had a formula you developed for $5 million to find rare diseases or something like that, that could be gone too. So true zero trust requires that you actually protect the memory of that destination server. And so one of the things this is one of the transformative things that can happen in the industry is using something called confidential computing to protect that memory, so that the memory is a place that your data and your application can go, where now you can manipulate it fully protected without the bad guys being able to steal the data, which is super expensive, or the formula, which may be just as expensive.
You talked before we turned the cameras on too about there being a fourth pillar that you have talked about and promoted. Right. In the zero trust construct. What's that look like?
Well, that is data, right? I mean, so if it's your network, if it's your endpoint, if it's your identity and access management, our pillars 1, 2, and 3, data protection is the fourth pillar. And this has recently been recognized all the way up through government, all the way through the White House, right? It was added over the last couple of years because it was recognized by the industry that the 3 pillars were not enough. But what some companies and some innovators are doing, and we happen to be one of those, my own company are using this whole concept of confidential computing to encrypt that memory so that you actually can protect the data across all 3 states of the data. So data's like matter, like we learned in school, solid, liquid, gas. Data is either at rest, in motion, or in use. And so being able to protect it while it's in use has been the problem. And so now we have confidential computing, which can allow you to protect the data across that entire life cycle. And that allows you to actually achieve zero trust.
Does the infrastructure that healthcare users, deliverers need in order to set up a zero trust environment the same as what other organizations use?
It is. It is actually, and it's all available to healthcare organizations, available whether they're government healthcare or whether they're private healthcare. We see large research organizations in federal healthcare that need help on both sides of the fence. They need help with data security, but also they need this application security help because they've developed their own, let's say, algorithms or formulas to transform the data. And the data that they're using, they're collecting from maybe literally thousands of endpoints. They could be rural doctors' offices, or it could be large healthcare groups. That stuff has to come together, be combined safely and securely so the bad guys can't see what you're doing, and then it has to be transformed, and then just the result returned back to the industry, right? But all of that technology is available in the healthcare space as it is in other parts of enterprise or government.
Patrick Conte of Fortanix.